Okay. uh, this video is designed to help prepare you for your assignment by taking a different algorithm, not binary search. So we're going to do bubble sort and kind of go over the same process that I tried to do in class with binary search, but we're going to go a little further and actually, you can kind of follow along and observe me implementing it here in real time. So, up at the top here, we have a representation of a list of integers, similar to your binary search. And I've already created some variables that are, and here we're just, these aren't Java variables yet, but it's just things that come up as, hey, I think we might want to be tracking some information. And actually I'm going to create another one here, and we'll call it swap. So to give you a high level, so bubble sort is a relatively inefficient algorithm which sorts an unsorted list by conceptually treating each number like it was a bubble of air underwater. And so if you kind of think of your list as this being the top and this being the bottom, and you flipped it on its side, then lighter numbers like 10 will bubble up through the list, in which case 10 would move into the place of 42 and 42 would move into the place of 10. And then once 10 was here, 10 would bubble past 12 and push 12 down. And as you keep doing this, so you start at the beginning, at which point the very first bubble is kind of a special case because we don't have anything to compare it to. It can't bubble up past any other bubble yet. So we actually want to start here. And once this bubble has either bubbled or not bubbled, right? Because if, well, okay, here's what we'll do. We'll just kind of run through it. So what we're going to do is first decide that we have a, oops. So we're going to have a sort index starting at 1, right? Because we don't need to evaluate index 0 because it can't bubble anywhere. We know that there's 1, 2, 3, 4, 5, 6, 7. There's 7 things in our list, and I'm putting down information that we currently know. This isn't necessarily information that is going to be used in our algorithm. It's more just, this is exploratory. This is saying, what do we know about what's going on or going to happen? And that's just helping to inform us in writing the algorithm and then figuring out how to implement it. But so we've got some extra variables here, but what we can really talk about. So let's see here. Not sure how helpful this is. This is real time. It's live. Sometimes I make mistakes. So anyway, let's just sort of look at it from what happens if we're starting at the very beginning, right? We have just going to do one step in bubble sort. So we start at sort index number 1, which has a value of 22 in it. So we want to look at the value here, and then we want to compare it to the very next bubble, right? The index that is 1 less than that current one, which is currently 0. So let's see, we're going to, and I'm writing some pseudocode down here just to kind of capture what bubble sort does. This isn't necessarily our implementation or necessarily the steps that we're going to follow exactly. It's just kind of capturing the gist of, hey, what does bubble sort do? In the same sense that we said, hey, what does binary search do? So we're going to grab the current bubble in the list, and then we're going to see how far current bubbles up through the list. So we kind of have a couple levels of complexity here. So grabbing the first, grabbing the current bubble in the list, that's pretty easy. We're just going to grab this guy. Now see how far this bubble bubbles up through the list. It's going to be more complex. We have some intermediary steps, right, in achieving this process. So we're going to compare our bubble to the bubble above it, right? And again, this is kind of conceptual, thinking about this is the top and this is the bottom. Lower index by 1. And then we're going to say if bubble is lighter, lower value, int value, then we're going to, if you just hit a tab, it'll go forward 4 spaces, so you can use that. So if the bubble is lighter, actually we'll do this. We'll just kind of create more of a skeleton here, because we know that we're going to have one of 2 conditions, and just as a prerequisite, we're running under the assumption that all of the numbers in our list are of equal value. I mean, the algorithm would still work one way or the other, but for right now, we'll just assume that they're all unique. And then if, so else, right? So if the bubble's lighter, then we're going to swap places, right? We're going to swap bubbles. So it's going to bubble up, right? It's going to bubbles up, which means it swaps places with the next bubble. Otherwise, it's going to stop, right? Which really, that just kind of means, stops bubble. Which, that sounds like it doesn't do anything, but we might actually, make some changes to some of the information that we're actually using to implement the algorithm. And then really, like, this whole thing is a process, right? We're going to get the current bubble in the list, and then, so we might actually be repeating on this. So if we do it just with 42, right? So we're assuming that this is the current bubble in the list. So we're at sort index 1, and currently our bubble is at 1 because we've talked about our bubble moving around. So it's currently at 1. So we perform the comparison. Is 42 less than list? And in this case, it's not, right? So we didn't bubble and we haven't changed anything. So that wasn't super interesting. So let's then consider that we're going to move on. We're going to perform another iteration, right? So we skipped 0 because there's nothing to compare. So we started with 1. We did a comparison, right? We see how far the current bubble is going to bubble through the list. It didn't go anywhere. So now we're going to move on to index 2. So So we've changed index 2, and our bubble needs to change to index 2, right? Because this is the current bubble we're going to look at. So is 10 less than 42? That answer is yes. So now we need to swap the positions of this bubble and this bubble, which means taking the value that is stored in list index 2 and copying it into list index 1. But we can't just mutually swap these in one statement. So instead, we're going to have to temporarily copy 42 into some, whoops, let's undo that. We'll just say that we're going to put 42 in here, right? We need to save the value in the bubble that we're going to move because it's going to get overwritten. So then, we're going to copy this guy, and so this was really kind of up here. So then we copied this guy here, so it bubbled up. So this is the, if bubbles lighter, bubble swaps places with the next bubble. So this is kind of this process that's happening here. So we moved 10 into here, and now our bubble is at index 1. So we've actually reduced the index of our bubble. And we swapped 42. Now once we do this, we don't need this value anymore, but there's something that would have been in here, so I don't think it's hurting anything for it to stay. And now we're still in here, so we're seeing how far this current bubble. So it seems like we have a loop inside of here, right? We have more stuff to do in checking the current bubble, because if this bubble is less than 12, which it is, then we're going to perform these steps again. So 12 would get copied up here, and I'm moving the shape, but the idea is that we have to copy 12 up here, and then we would copy 10 here. So very briefly, right, 10 is going to be in both places, and then we're going to copy from what our swap is into here, and now we've successfully completed another. We've evaluated index 2, and we've gone through 1 to 0, and 10 has bubbled all the way as far as it can go. In fact, when we can at a high level look at our list, nothing else is going to get past 10 because it's the lowest number in the list. But your algorithm won't necessarily know that. It has to have steps that account for however far that would be. So see how far our current bubble. So we have to have some kind of iterate over all. Well, let's see. Well, we have a loop, right? We don't necessarily know what kind, but else. Whoops. Stops bubbling. Okay. Ends loop. So now remember that when we're creating a loop, we have some kind of condition, right? So done bubbling. Yeah, sure, that'll work, right? Done bubbling. So we have a we would have a boolean appear somewhere, but we're kind of keeping track, kind of in two places, which is fine. So the current bubble, until it's done bubbling, so let's say that this is going to be a while, and then we're going to invert. We're going to say, or actually, while not done bubbling, or while will bubble. That's fine, right? So while it's true that the current bubble will bubble up through the list, we'll keep going, right? And then we'll stop bubbling. So we're going to say, sets will bubble false. That's cool. Right, so we don't have to change will bubble if we're doing this actually bubbling up thing, right? Here's where we're actually going to swap the places in the list, which, so this is really going to be multiple steps that happen under here, which aren't necessarily, it's just discrete steps, but this is kind of like a higher level description. So we're going to, copy next bubble into swap, and then copy bubble into next index, and then we're going to copy bubble from swap into bubble index, right? So in other words, where our bubble originally was, right? Where we are in the bubbling. And then once we've done that, we would want to decrement our bubble index, right? So we want to, we're now, our bubble has moved up one in the list, so we need to look at a lower index so that we can compare it to the next bubble. So what that means is we know that we're going to have this will bubble thing. So we kind of go back and forth here, and this is just my process. Now granted, I'm experienced, not a whole lot recently practiced coder, but so this is my process, and you can just kind of follow along, and if you're seeing things, hey, I would have done that differently, that's fine, and you can maybe work through this problem either with me or doing the same things that I'm doing, or running through your own process and writing your own notes in your own pseudocode in BlueJ, and see how things go in your process. But we know that we have a Boolean, and I'm going to call it will bubble up. And right now we're going to assume that that is true. Because if we don't assume that, then this never happens, and we don't look at anything. But we might end up changing this. We'll just run with it for just a second. Coding's a really dynamic process. You need to make changes and adapt and add stuff and take stuff away, and that's fine. It's like a whole bunch of Legos. So we've created that, and then we had bubble index, right? So we need to keep track, and we'll use an integer since indices are easy to track with integers. So we have an integer of bubble index, and we know that when we start out of our algorithm, that's just going to be 1. We're never going to start with anything different than 1 based on how we're doing this. Now just to point out, we're kind of conceptualizing that the beginning of the index are the light bubbles, and the end of the index are the heavy bubbles. And we could swap that. We could do it differently. Or we could say that, that instead of things bubbling up, that, the heavier numbers are going to fall down through the list, and that's perfectly acceptable. You're just going to be changing how the logic works, right? So rather than this moving to lower indices because it's bubbling up, you would then be saying that a heavy number would be falling down through the indices, which in this case might feel more intuitive to you, because rather than decrementing an index, we would increment an index. It's however feels intuitive to you. There's no real right, there's no real wrong if your algorithm works. So we've got our bubble index, and then we have to know where we were sorting from. Like, so how far did we get through this list? Because eventually we're going to run through this on all of the numbers that we had available, at which point we've completed the algorithm and the list should be sorted. So we have an int sort index, and when we start, we also start with 1. And then, like, we have this current bubble in the list. Well, okay, that's our bubble index. We don't actually need the value just yet. So let's see. But we know, right? We're going to grab out the value. So here, little bubble. Yeah, okay, that's cool. So what we're going to do is we're going to say integer current bubble. And I'm declaring it, and so I need to determine, okay, so equals, oh, yeah, we have unsorted list, and we are at, so our bubble index and our sort index are currently the one. While it doesn't make any difference in terms of how this is going to execute, we're going to move that guy to the beginning, just because that makes more sense to me, because actually, it's a good point. Okay, we have some default values here. That's okay. You know what? I think I'm going to while. Actually, we'll do a for loop, just because we're going to go, 0, 1, 2, 3, or really, 1, 2, 3, 4, 5, however many things were in this list. We're going to go over all of them just one by one. So a for loop is pretty intuitive for that. Whoops, not if I don't write it correctly. And also, what we're going to do is start just creating some, documentation for ourselves. So this is truth of whether or not current bubble, current value is lighter. So this is just, let's see, our sort index. So this is how far into the list our algorithm has sorted so far. Oops. And then this is how far up our current bubble has moved towards the top. Alright, so here so we're gonna, iterate over entire list except first index, right? And that's just because this first bubble, we don't have anything to compare it to. So we're going to skip over. So we're going to say that okay, so our outermost loop needs to be moving over this entire list, right? Because that's at a higher level, that's what our algorithm needs to do. is go over all of these numbers. So for and so I could declare sort index in here. That would be perfectly fine. Yeah, because it's not going to have any context outside of here, which is, that's cool. Int sort index. So equals 1. So up here, I mean, it's fine that I declared it, or assigned it, but instead, just to be a little cleaner, I'm just going to say, bam, it exists, right? And part of the reason that I'm putting this up here and not doing the entire declaration, so I haven't included a type before sort index because we declared it here, and I'm doing that because that just lets me include this additional text up here so I can kind of keep track of what's happening. So sort index equals 1. So this is going to initialize sort index when we begin looking over our list. And then we're going to say if, so long as the sort index is less than unsorted list dot length, right? Because we're going to go over the entire list. Because we won't know, like here, 41, okay, it will move past 42, but it might not have moved, but we don't know that until we look at it. So we have to look at the entire list. And then sort index plus plus. So you will note that we've kind of run past this little green line on the far side of BlueJ. And that's an indicator that we've actually gone past 80 characters, which by convention, well, guess what? We can fix that. Bam! So normally you don't include spaces inside of your parenthesis for stuff like this. So we're just coming in at 80 characters, and that's convention. Other instructors may gripe at you if you go past 80 characters. And the real reason that we stick with that is just, older IDE environments couldn't display more than 80 characters on a line. I could drag this guy over and we could show more in one line, but it's just a convention to make sure that whatever kind of IDE somebody is using, if they're looking at your code, they can see this whole statement on one line. And there's ways to break statements across multiple lines. So if you have something that just because of your variable names or the expressions that you're using, this statement would go past one line, and there are ways to break it up to make it legible and fit within 80 lines. But anyway, this statement here is going to start at the first element, and it's going to go all the way through the list. So that's all we're doing here. There's nothing more inside of it. So now we need to actually grab out what our bubble is, right? So we don't have anything for the current bubble. And we can do that in here now that I actually have some structure. So get value of current bubble. So int bubble equals, and oh, actually, I started doing it down here. That's fine. We'll just delete that. Equals unsorted list. And right now, actually, let's see, bubble index. Okay, so we're going to actually grab out the value of the unsorted list at our bubble index. Now something that I do need to do above that is, since as we move through the list, right, so we started originally looking at one and, well, 42 was here the first time, right? And it didn't go anywhere. And then we needed to move to index 2 when we started looking at 10. So that meant that our bubble index had to be reset every time we moved to a new sort index. So we have to make sure that int bubble index equals sort index. So that's going to make sure that we reset our bubble every time we move across doing our overall sorting, right? So the bubbles get set to the sort, and then we're going to grab out the value, and then we're going to say will bubble up, which, you know, it could be inside this for loop too. That's fine. Some may tell you that by convention, you know, if you're going to only use something inside this loop, you should declare it here. Other people might tell you that all the variables you're going to use for your whole algorithm, you know, this entire method, should be up here, and then just use them down here. I'm not going to worry about that for your assignment. I'm just saying that there's some different conventions, and more often than not, what's most natural is anything that you would have used inside of here, you'll declare inside of here. But again, it's sort of what feels right to you and intuitive to you. But we're going to say that will bubble up equals, so now we have to have a comparison, right, between whatever's here and whatever's before it. So so now we have a comparison, and I'm just going to throw this into parentheses so it kind of stands out as a Boolean expression. But if the value of our bubble is less than unsorted list at bubble index -1, right? So if this is true, then our bubble's going to bubble, right? So actually, we'll bubble up while